students, today we shall discuss the use of specialized function in the theory of Laplace transform. How can we use or how can we apply the theory of specialized function we have defined? Unit step function, displaced unit step function, rectangular wave or pulse function. These are the specialized class of function. How we can better use these functions to transform, to express any functions in the form of this unit step function. So we shall today now study express any function in the form of unit step function. Unit step function. So, let us quickly revise, take a recap of all these three functions. Unit step functions, displayed or delayed unit step function, and the rectangular wave function. U of t is called as unit step function. It is defined as 0 when t is negative and is equal to 1 when t is non-negative. Its graph is like this, up to infinity. This t axis, this is u of t axis. We have also seen that effect of this unit step function to any arbitrary function. So, if this is any f arbitrary function, then u of t into f of t, this is, then u of t into f of t would be the portion of this curve, portion of this f of t towards the right of t axis. It curtails this negative part. This is t axis. We have also seen that the Laplace transform of this function u of t, Laplace transform of this function u of t is 1 by s. That was the first function we discussed. Then u of t minus a. This is called as the delayed or displaced unit step function. Is defined as 0 when t is less than a. It is equal to 1 when t is greater than or equal to a. Its graph is, if this is point p is equal to a, then this is t axis, this is 1, t f of u of t minus a is equal to 1 up to infinity. If this is f of t curve, this is point a, then the effect of f of t into u of t minus a is this portion of curve. This, so it allows the portion of that curve which is greater than or equal to a. Then we have also seen the rectangular wave function. Rectangular wave function. It is also called as pulse function. It is denoted by u of t minus a minus u of t minus b. Here a is less than b. Note this. Now, it is defined as it is equal to 0 when t is less than a. It is equal to 1 when t lies between a to b. It is again 0 when t is greater than or equal to b. Now we shall see effect of this multiplication of this rectangular wave function to f of t. F of t into u of t minus a minus u of t minus b is equal to 0 when t is less than a. It is equal to f of t when t lies between a to b is again 0 when t exceeds b. Because of this, because whenever t is less than a, value of this rectangular wave function is 0. So 0 into f of t is 0. In this band a to b, it is 1. So 1 into f of t is 1. In this band from t equal to b and onwards, it is 0. So 0 into f of t is 0. So if this is t equal to a, t equal to b, now from this definition, it is equal to 0 when t is less than a, then it takes the value 1. This value point is 1. This is t axis. So it is 1 from a to b. Again at b and greater than b, it drops down to 0. Due to its shape, it is also called as the rectangular wave function. So if this is any function f of t, these are the point a and b, then f of t into u of t minus a minus u of t minus b, its plot would be equal to only portion of this curve between a and b. It cuts the portion towards the left of t equal to a and towards the right of t equal to b. From t equal to a to t equal to b, it allows only those portions of f of t. That is the effect of this rectangular wave function. Now, one most important result, Laplace transform of most important result. Laplace transform of f of t into u of t minus a. We know that how it is defined. We have already defined. It is equal to, when t is less than a, this u of t minus a is 0. When t is greater than or equal to a, u of t minus a is 1. 1 into f of t is f of t. So, Laplace transform of, this is the function defined. Now Laplace transform of f of t into u of t minus a definition is integral 0 to infinity e raised to power minus st into this function f of t into u of t minus a into dt. This is equal to इंटीग्रल, ये दो बैंड में डिफाइंड है, 0 to a और a to infinity. ये फंक्शन f of t into u of t minus a, it is मल्टी बैंड फंक्शन. 0 to a में इसकी वैल्यू 0 है और फ्रॉम a t इक्वल टू a एंड ऑनवर्ड्स उसकी वैल्यू f of t है. So 0 to a e raised to power minus st into f of t into u of t minus a dt plus a to infinity e raised to power minus st into f of t into u of t minus a dt. So in this 0 to a, u of t minus a is 0. So this is 0. So we have only this integral a to infinity e raised to power minus st into f of t. In this band a and onwards, this f of t into u of t minus a, it is f of t. So this product is f of t simply. See here, माइंड ओवर द लिमिट्स. यहां पर लिमिट्स a टू इंफिनिटी है, 0 टू इंफिनिटी नहीं है. इसको 0 टू इंफिनिटी में करने के लिए हम t माइनस a इक्वल टू x पुट करेंगे. t माइनस a इज इक्वल टू x पुट करें. dt इज इक्वल टू dx हो जाएगा, नंबर एक. दूसरी बात, when this t is equal to a, x is equal to 0 हो गया ये. When t is infinity, x is also infinity. So a to infinity transform हो गई 0 to infinity. So 0 to infinity e raised to power minus s times t. T is equal to, from this substitution, a plus x into f of a plus x and dt is dx. This is transformed into variable x. So e raised to power minus as, ये constant है, independent of x. 0 to infinity e raised to power minus s x into f of a plus x dx. Or in our contemporary usual language, e raised to power minus a integral 0 to infinity e raised to power minus st f of a plus t. यहां पर x has now been, dummy variable x has now been replaced by t, just to understand its conversion. तो ये हो गया हमारा Laplace transform of f of t into u of t minus a is equal to e raised to power minus as. और ये इंटीग्रल है, दिस इज इक्वल टू e raised to power minus as into, ये है Laplace transform of this f of a plus f of t plus a. This is the Laplace transform of f of t into u of t minus a. This is most important. We are using this in the next example. Now, how to express a function in the form of USF. USF means unit step function. f1 of t, f2 of t, f3 of t and f4 of t. Let f of t be is equal to, ये f of t 4 बैंड में डिफाइंड है, मल्टी बैंड फंक्शन है, f1, f2, f3 और f1. So f of t is equal to f1 of t when t lies between 0 to a तक, 0 to a तक वो f1 of t है, and from a to b it becomes f2 of t, and from b to c it is f3 of t, and c from c and onwards t greater than or equal to c. So how shall we express this in the form of unit step function? How it is defined like this? ये points है A, B, C. From 0 to A it is F1. Like this, F1. ये plot समझो F1 है. And from A to B it is F2. This is F2. From B to C it is F3. ये F3. And from C and onwards it is F4. ये F4 is up to infinity. So our this function f is like this: f1, f2, f3 and f4. So how to express this in the form of unit step function? Now, ये बैंड का from 0 to a इतना ही पोर्शन हमको कैसे मिलेगा? रेक्टेंगुलर वेव फंक्शन से मल्टीप्लाई करके. So this is f of t is equal to f1 of t into its band from 0 to a, u of t minus 0 minus u of t minus a. ये सिर्फ f1 डिफाइन करता है, इतना ही पोर्शन f1, और f2 प्लस f2 इंटू इसका बैंड है u of t minus a to t minus b, u of t minus a minus u of t minus b. f3 of t into u of t minus b minus u of t minus c plus, अब ये f4 फ्रॉम पॉइंट c एंड ऑनवर्ड्स, ये डिस्प्लेस्ड यूनिट स्टेप फंक्शन है. इसको ये f4 ऑफ t कैसे मिलेगा हमको? फ्रॉम c एंड ऑनवर्ड्स इट इज इक्वल टू f4 ऑफ t इंटू u ऑफ t माइनस c, because from c and onwards u of t minus c is 1, so 1 into f4 is 4. So this is the expression of this u of f of t in the form of rectangular wave function. But now we shall write this in a handsome manner. How? We shall write each term. f1 of t into u of t minus 0 means u of t. Now, what is the multiple of u of t minus a? It is f2 minus f1 plus f2 of t minus f1 of t into u of t minus a. Now what are the multiples of u of t minus b? It is f3 minus f2 plus u of t minus b. और u of t minus c के मल्टीपल्स कांस्टेंट क्या है? u of t minus c ये f4 minus f3 plus f4 minus f3 times u of t minus c. This has now been written in a condensed form. So how to remember this? In the first and second band, first band is 0 to a, second band is from a to b. In this two bands, what is common? A. So first term is always f1 of t into u of t minus 0. This. Plus second term is f2 minus f1, because in this both the bands a is common. A is common. So its multiple is u of t minus a. So f2 minus f1 into u of t minus a. Now in the second and third band, b seems to be common. So in the third term, u of t minus b would be common. So f3 minus f2 into u of t minus b. In third and fourth band, c is common. Interval point c is common. So u of t minus c would be the multiple, and we shall write f4 minus f3. So that is how we express any such multi-band function in the form of unit step function. Just to identify these common points a. So u of t minus a into f2 minus f1, u of t minus b into f3 minus f2, plus u of t minus c into f4 minus f3. Plus this is first term, u f1 of t into u of t minus 0. This term, this is independent term. So we shall take one example and then we shall stop. Now express f of t in the form of unit step function, and hence find its Laplace transform. The function defined is it is equal to e raised to power t into cos t, suppose when t lies between 0 to pi. It is equal to e raised to power t into sin t when t is greater than or equal to pi. So it is defined into two band only. 0 to infinity कैसा split हुआ है? From 0 to pi or from pi equal pi to infinity, ऐसे defined है. So f of t is equal to here. पहली टर्म तो ये होगी e raised to power t cos t into u of t. Note this. अब this into ये 0 कंसिडर कर लिया. अब ये बैंड में और ये बैंड में क्या कॉमन है? पाई कॉमन है. तो सेकेंड टर्म में मल्टीपल होगा u of t माइनस पाई into f2 minus f1 e raised to power t into sin t minus cos t. Okay. So this function is equal to this function. So I have expressed the function in the form of unit step function. Now to find out the Laplace transform, taking Laplace transform of both sides. Laplace transform of left hand side f of t is equal to Laplace transform of first term e raised to power t cos of t into u of t plus Laplace transform of e raised to power t sin t minus cos t into u of t minus pi. Further equal to Laplace transform of e raised to power t cos t f of t into u of t is equal to f of t. So plus Laplace transform of e raised to power t sin t minus cos t into u of t minus pi. Here multiplicand is e raised to power 1t. यहाँ पर multiplication by e raised to power at. फर्स्ट शिफ्ट प्रॉपर्टी यूज कर रहा हूं मैं यहाँ पर e raised to power t किससे मल्टीप्लाइड है? cos of t से. सो f of t यहाँ पर cos of t है. उसका लैप्लास ट्रांसफॉर्म क्या है? s अपॉन s स्क्वायर प्लस a स्क्वायर. a is 1. Put or replace s by s minus 1 plus. Now this is important, most important. This is of the type Laplace transform of f of t into u of t minus a type. We have shown that Laplace transform of f of t into u of t minus a is equal to e raised to power minus as into Laplace transform of f of t equal to t plus a. So here value of a is pi. So I will use this formula. It is equal to e raised to power minus pi s into Laplace transform of e raised to power t plus pi into sine of t plus pi minus cos of t plus pi. That's it. I have used this formula. Further, here replace s by s minus 1 because this is f of s minus 1. S minus 1 upon s minus 1 whole square plus 1 plus e raised to power minus pi s into Laplace of. This is e raised to power t into e raised to power pi. E raised to power pi into e raised to power t. Sine of t plus pi. It is sine t into cos pi plus cos t into sine pi. So it is equal to minus sine t minus. What is cos t? Cos pi. Cos of t plus pi. It is cos t cos pi minus sin t sin pi. So cos of t plus pi is minus cos of t. So that is further equal to s minus 1 upon s square minus 2s plus 2 plus e raised to power minus pi s into e raised to power pi into Laplace of e raised to power t into cos t minus sin t. So it is further equal to s minus 1 upon s square minus 2s plus 2 plus e raised to power minus pi s into e raised to power pi. Again, this function is multiplied by e raised to power t. I am going to use the first shift property here. इसके लैपलास ट्रांसफॉर्म में s इक्वल टू s माइनस वन पुट करना है, हो गया. इसका लैपलास है s अपॉन s स्क्वायर प्लस वन, सो s माइनस वन अपॉन s माइनस वन स्क्वायर प्लस वन माइनस साइन का लैपलास साइन t का वन अपॉन s माइनस वन होल स्क्वायर प्लस वन. That is the final answer of the Laplace transform of this function after expressing this function in the form of the unit step functions. Thank you very, very much.